if you are considering two mediums, that is, the lens will be having a refractive index of N2 and the outside medium will be having the refractive index of N1. So 1 by V minus 1 by U is equal to N2 minus N1 divided by N1 into 1 by R1 minus 1 by R2. That is lens maker's formula. The magnification of this particular lens again is very easy. It is given by M is equal to V by U. Hey all, I'm Hari Krishnan from the Department of Physics, Vidhyaashram PU College, the Temple of Excellence, and we are going to continue our session on optical instruments and optics. So let's see. Now we are going to deal with an interesting topic that is known as lens maker's formula. So again, we were dealing with what happens when light incidents a curved surface. Now what happens when light incidents, or simply it's a fancy way of saying what happens when light incidents a lens which has two curved surfaces. How will we form an equation for that particular lens? So we know that if light incidents a curved surface, we already have a formula for that. But now here there are two curved surfaces. So what happens then? What will be the change in equation? That is what we are going to focus and derive in lens maker's formula. So again, if I imagine the same set of situations, that is, instead of having an object with a height, I'm imagining a point object here, and then we can say that, okay, light will be incidenting on this particular surface, and as you can see here, there are two surfaces. So if there was only one surface, then I can say that, okay, after incidenting on this particular surface, light will be converging here, or passing through that particular point on the principal axis, and that will be forming an image. So here object O is there, and similarly an image I or I dash will be formed in that particular point. But there are two surfaces, which means that after this will actually refract and produce an actual image here. So again, we know that this particular distance is nothing but object distance U, and this particular distance is nothing but image distance, which is indicated by V, and this particular distance is V dash. Now, so why is there V and V dash? So that is because here, if we are considering two curved surfaces, then automatically we have to assume that the second image is going to act as object for the second surface. That is, in the first surface we'll have, okay, this will be the object ray, and this will be the image ray. That is no problem. But when we are considering the second surface, this will be acting as the object and this will be acting as the image. So you have to be very careful and understand that, okay, I dash will be acting as the object when we are considering the second curved surface. And again, if you are considering two mediums, that is, the lens will be having a refractive index of N2 and the outside medium will be having the refractive index of N1. So light is coming in from a different medium, entering into a different medium, getting refracted and forming an image of the principal axis. So again, it is very simple. We are going to apply equation that we found in the previous session, that is simply refraction at a curved surface. So applying refraction at a curved surface formula, we have N2 by V minus N1 by U is equal to N2 by R minus N1 by R. Right. So again, from this formula, we are going to apply this on the first curved surface and on the second curved surface. Again, a point object is being projected. Again, this is the incident ray, this is the point object, and here we have the refracted ray forming the image if we consider the second surface altogether. Now, if you're only considering the first surface, then the image will be formed here. And now, if you're considering the second surface, this will be acting as the image. That is, the initial image formed will be acting as the object for the second surface, and this will be the image that is formed. This will be the point object, and this will be the image formed for that particular point object when we are considering curved surface number 1. Now, if you're considering curved surface number 2, then this I dash will be acting as the object and this I will be acting as the image. Which means that for curved surface number 1, or simply for surface 1, that is this particular surface, we can redefine these particular terms. That is, what is N1, what is N2, and what is V, what is U, and what is R. All that we can redefine, because depending on if you're choosing this surface or this surface, the object, the image, everything differs. It can be V dash, it can be V, it can be U. So let's see. So again, N1 is nothing but N1, that is medium number 1. From here, it is entering into this particular secondary medium. So N1 is nothing but N1, N2 is also nothing but N2, and V actually becomes V dash, because it is not refracting in the second surface and landing here. It is only refracting through the first surface and landing here, forming an image on I dash, which means the image distance is now V dash. The image distance is now V dash, and object distance is nothing but U itself. And radius of curvature, that is from here to here, let's call it as R1. So this will be R1. So these are the initial considerations. Then we can see that, okay, this particular equation can be transformed into, N2 divided by, instead of V, it is V dash. So N2 divided by V dash minus N1 divided by U. There is no change in that. So this will be equal to 1 by R1 into N2 minus N1. Right. From the equation of refraction at a curved surface, we can write this equation as transformed as you see now. So again, V becomes V dash, that is the only reference, and R becomes R1. That is the only slight change we brought in this particular equation. And now we'll call this as equation number 1. Now again, for second curved surface, so this is for surface number 1, and for surface number 2, surface 2, again, the same things we have to write down. That is what N1 will become, what N2 will become, what V will become, what U will become, what R will become. So automatically here N1 is the first material medium. So here light is not actually entering from N1 to N2, but rather from N2 to N1. So automatically the N1 and N2 will be flipped. So N1 and N2 will be flipped, because here this particular equation represents, okay, light is traveling from the secondary medium to the primary medium, like that. So here we have to flip it in order to balance the equation. Now here, what is the object? Here we know that this particular image that is first formed is going to act as the object. So since I dash is acting as the object, this particular V dash, that is the image distance for the first curved surface, is now going to be the object distance. U will become V dash and V will just be V itself. That is the image that is formed. So V will be V and R will be R2. Right. R will be R2. So then we can actually say that this equation now can be written as N1 by V minus N2 by, instead of U, we are going to write V dash. So N1 by V minus N2 by V dash is actually equal to 1 by R2 into N1 minus N2. That is equation number 2. So we have a relation 1 and 2. Now what we are going to do is that we are going to add 1 plus 2, which implies we are going to add these two equations, left hand side plus left hand side, right hand side plus right hand side. So adding 1 and 2, we will get N2 by V dash minus N1 by U plus N1 by V minus N2 by V dash is equal to N2 minus N1 by R1 plus N1 minus N2 divided by R2. Now again, if you see here is that N1 minus U, again see here, we can see that N2 by V dash and minus N2 by V dash is there. So when we open the bracket, these two terms will get cancelled and the only remaining terms will be N1 by V minus N1 by U will be equal to N2 minus N1, which I am taking as common, plus 1 by R1 minus 1 by R2, right? So again, if I take N1 common factor here, I can write it as N1 into 1 by V minus 1 by U is equal to N2 minus N1 into 1 by R1 minus 1 by R2, right? So if I shift this N to the other side, I can say that I have the lens maker's formula as 1 by V minus 1 by U is equal to N2 minus N1 divided by N1 into 1 by R1 minus 1 by R2. So this equation is known as the lens maker's formula. So this particular equation is known as lens maker's formula. And again, don't worry about this plus sign and this minus sign, because when we re-multiply this, we need a positive sign in between. That is why when we take common factor outside, that will become a minus sign. So don't stress over it and worry, okay, suddenly it became a minus sign. So because when we re-multiply it, it should be a positive sign. That is why it happens. So 1 by V minus 1 by U is equal to N2 minus N1 divided by N1 into 1 by R1 minus 1 by R2. That is lens maker's formula. Similarly, we have one more equation to find out, and that is known as lens's formula or simply lens formula. This happens as a special case of the previous equation we just derived. So what happens when the object is at infinity? When the object is at infinity, then U will be equal to infinity. When U is equal to infinity, what will happen? So again, if you have a lens like this, and this is the principal axis, if the object is at infinity, what happens? All the rays will converge at one particular point, and that particular point is nothing but the focus. So the equation, that is 1 by V minus 1 by U is equal to N2 minus N1 divided by N1 into 1 by R1 minus 1 by R2 will now become, where U becomes infinity and V becomes the focal length, right? The focal length, that is the length from here to here, that is nothing but the focal length from the center to that particular point where the images or the rays are being focused, that is nothing but focal length. So V becomes F, let's put it as small f. So V becomes F. Then automatically this equation will be transformed into 1 by F minus 1 by infinity. 1 by infinity is nothing but 0 is equal to N2 minus N1 divided by N1 into 1 by R1 minus 1 by R2. Right. So we can say that this will be the final output. So if we name this as equation number 2, then we can compare equation number 1 and 2. Equation number 1 being the original lens's formula. So when equation number 1 being the original lens's formula is compared with this particular equation, we can actually say that the right hand side of both the equations are same and the left hand side is the only factor that is differing, because V became F and U became infinity. So on the left hand side of equation number 2, there is only 1 by F. And on the equation number 1, on the left hand side, it is 1 by V minus 1 by U. So this is the result, the famous result that is known as the lens formula, which is nothing but 1 by V minus 1 by U is equal to 1 by F. And finally, one more thing we have to know is the magnification. The magnification of this particular lens, again, is very easy. It is given by M is equal to V by U. There is no negative sign because it is not on the left hand side. These are the only things you need to know about lens's formula and lens maker's formula. Moving on, we have to know just one more thing, that is the power of a lens. The power of a lens is defined as the reciprocal of its focal length. How much powerful a lens is, how much enhancing that particular lens is. So power of a lens is defined as the reciprocal of the focal length, and its unit is actually the SI unit of power is nothing but diopter. Diopter is the SI unit of power, and power is defined as the reciprocal of focal length expressed in terms of meters. So that is all about lens maker's formula and lenses. Now we are going to see what happens when two very thin lenses are brought together. That is combination of lenses. What happens to the light when it is passing through that particular set of lenses which are brought very close to each other. So we'll have a theoretical relation for that also. Now again, we are going to consider two very thin lenses which are brought very close to each other so that their centers almost coincide with each other. So that is why I am able to draw this particular figure like this. That is because this is only for a demonstrative purpose. Don't think that light actually bends like this in the figure. But the lenses are in fact very close to each other so that their optical centers, that is, this lenses have different optical centers here, right? But theoretically, we are assuming that the lenses are so thin, very thin, that their optical centers actually coincide with each other. So we have a common center. So that is why we can apply and prove this particular ray diagram, or simply apply this geometrical conditions and prove this particular formula. So again, the same conditions as before, that is, I dash will be the image for the first lens, and that will act as the object in the case of the second lens. So again, whatever we took in the lens maker's formula, the same concept is being taken again. That is, I dash is now being the image of the first lens, will act as the object in the case of the second lens when light is refracting. So again, in that particular case, we take what is known as the lens's formula, that is 1 by V minus 1 by U is equal to 1 by F. So that is the initial formula which we consider, and then now we apply the same thing we did to lens maker's formula. That is, instead of V, U and F, whatever is there in the figure, according to that we will apply and substitute and we will find the result. So when we are considering the first lens, what will V become? What will U become? What will F become? That is the first thing we are going to find out. Again, for first lens, U is nothing but U, and V will become V dash, and F, let us call that F1, the focal length of the first lens. Let us call it as F1. From the center to the particular focus point, it is known as focal length. So let us take it as F1. If I take it as F1, then I can write this particular equation as 1 by V dash minus 1 by U is equal to 1 by F1. This is the equation for the first lens. And similarly, if I consider the second lens, then I can say that, okay, what will V become? What will U become? What will F become? Automatically, we know that I is now going to be the image, which means V will be V itself. U will now be V dash, as I dash is the object. So U will become V dash, and F, let's call it as F2. So this particular equation will be transformed as 1 by V minus 1 by V dash is equal to 1 by F2. So this will be equation number 3. Now the only thing we are going to do is that we are going to add equation 2 and equation number 3. So we are going to add equation 2 plus equation number 3, which will give us 1 by V dash. So 1 by V dash minus 1 by U plus 1 by V minus 1 by V dash. This will be on the left hand side, and on the right hand side we have 1 by F1 plus 1 by F2, right? So on the left hand side, we have 1 by v dash and minus 1 by v dash. It cancels out each other. Then it will be 1 by v minus 1 by u is equal to 1 by f1 plus 1 by f2. Right. So the final equation will be 1 by v minus 1 by u is equal to 1 by f1 plus 1 by f2. Right. This will be the final equation. So instead of 1 by v minus 1 by u is equal to being f, it is now 1 by f1 plus 1 by f2, which means that 1 by f, that is the net focal effect, is now 1 by f1 plus 1 by f2. That is, when we combine the lenses, when there are more than one lens being combined, then we can see that its effect is being added up. So this is known as effective focal length. This is known as effective focal length. And similarly, if we take the case of power also, we can say that power is nothing but power P is nothing but 1 by F expressed in meters. So here, if effective focal length is the sum of different focal lengths, then we can say that the power will also be equal to, that is, effective power will be equal to P1 plus P2 plus etc. like that. That will be the effective power. And the only difference that will come is in the magnification, because magnification, if we use different types of lenses, if we club together two different types of lenses, instead of being M1 plus M2, it is going to be M1 times M2. You don't need to know how we got this particular result. You just need to know what will be the effective output if lenses are placed together. What will be the effective focal length? What will be the effective power? What will be the effective magnification? If the only difference will be in the case of magnification, other than that, it is very simple. So that is a very small derivation and a very small concept for you from ray optics and optical instruments. So next time I'll see you all with an interesting derivation that is about prisms. So I'll see you all in the next class. Thank you.